Hello, this is one constant acceleration question that you have in your mechanics paper in the AES from June 2022, and it's question 1. I'm going to show you how you can get full marks on this. So the point A is 1.8 vertically above horizontal ground. At time t0, a small stone is projected vertically upwards with speed u from point A. Time t equal t seconds, the stone hits the ground. The speed for the stone when it hits the ground is 10 meters per second. And an initial model of the motion of the stone as it moves from A to where it hits the ground, the stone is modeled as a particle moving freely under gravity. The acceleration is 10 meters per second. Be careful because this is an unusual value. And using the model, we have to find a value of u. So the first thing, we have a particle is projected up, is going to go up and then down. The point is not in the ground, so this point A where it's projected is 1.8 meters above the ground. So this distance here is 1.8 meters. We don't know the initial velocity is what they ask, so the initial velocity is going to be u, and we need to find it, but we know the final velocity, which is going to be 10 meters per second. So what we're going to do is to use Subat equations, and remember when we use Subat, my recommendation is that you write Subat and you write everything that you know. We are going to choose a positive direction. Let's say positive is up. So our displacement from here to here, because remember for these questions we can do like in steps, so from here to the top, from the top to the end, or from the beginning to end altogether. I would do from beginning to end because we know the final velocity, the initial velocity, and the displacement. So the displacement from here to here, this is the origin, and I say this is positive, is going to be minus 1.8. Yeah, because it's down and it's from here. So displacement is minus 1.8. The initial velocity is what I need. Final velocity is down. Yeah, when the ball or the particle, wherever it is, it hits the ground, it's going to be down. So if I say positive is up, this velocity is going to be minus 10. And acceleration, we say we are going to use 10. And is going to point down because the gravity always pointed down. So it's going to be again minus 10 meters per second squared. And the time we don't need at the moment. So I'm going to choose one Subat equation without t. Remember that my Subat equations that are here in your formula booklet are 5 equations where each of them are missing one of the variables. So when we have to choose the Subat equation, what we are going to do is we are going to use one that has the variables that we know and the one that we need. And it is going to miss the one that we don't need and we don't have, which is t. So in this case, if I go to my Subat equations, I'm going to use this one that has no t. So I'm going to use v squared is u squared plus 2as. V squared is minus 10 squared. U squared is what I need. And minus, I'm going to write minus because then acceleration is negative. No, and plus because acceleration is negative, but displacement is negative. So it's going to be plus 1.8. And from here, I get two values of u, one positive, one negative. And I'm going to pick the positive one because it's in the direction that I consider positive. And this is going to be just 8 meters per second. So this is the first one. The marks are for using Subat equations, so for the correct method. The other one is for substituting correctly in the equation with the signs and everything correct. And the last one is for the answer. Then this is the first one. Then B, they say find the value of t. So I'm going to use exactly the same. So from here to here, because they asked me the time from here to here. So I'm going to use the same values. So for B, if I write Subat again, my displacement is going to be the same. Initial velocity now I know is 8. meters per second, final velocity minus 10, acceleration minus 10, and I need the time. So I can use any equation, and I can use v is u plus at, which is probably the simplest. So velocity, final velocity is minus 10, initial velocity is 8, acceleration is minus 10 times t. So the time is going to be minus 18 divided by 10, minus 10, 1.8. So this is the time. Yeah, so this is meters second square. This is the next part, and you get the marks for the method, so for using the super equation, and for the answer. Then C, they say, suggest one refinement apart from including a resistance, be careful, don't mention this again, that would make the model more realistic. So my recommendation is that when you are doing questions where you have gravity, you just say a more accurate value of the gravity. So that would be 100% sure a mark without any complication. So more accurate value of gravity. You can say other things like the wind effect, or and I'm going to show you what they say in the mark scheme. So apart from more accurate value of gravity, they say wind effects, spin of the stone, include dimensions of the stone, shape, size, stone, variable acceleration, so different things. But my recommendation is just for a safe answer, just talk about the gravity. And then D, this is the part that is confusing almost everyone. And I understand why. I would say my first reaction is the same that yours. I just seen this question before, and now I'm familiar, and I have this discussion with so many students. So let me show you. So in reality, the stone will not move freely under gravity and will be subject to a resistance. Explain how this would affect your answer to part A. Part A is when they were asking us the initial velocity. So your first reaction is, I have a resistance, therefore the particle is going to move slower. So my velocity is going to be less, it's going to be smaller. But that's not what is happening. What they say, so you are trying to find u. So the stone falls into the ground with this speed. Yeah, and you are trying to find u. If you want the stone to arrive to the ground with this speed, and you have a resistance, that means that you have to project it with more speed if you want to overcome that air resistance and arrive to the ground with that speed. Yeah, so your initial velocity will need to be larger, which I don't think is very intuitive, unless you reason that way. Yeah, but your initial velocity must be larger, and this will be your mark. And I know when you see the mark scheme and you see this, you are confused because you expect it to be smaller because there is air resistance. And if that's the case, I promise you are not the only one. So this is the examiner's report. You know, the examiners, after marking the exams, they make some notes available for everyone. And about this question, they say in the final part, correct answers were in the minority. Yeah, which most candidates failing to appreciate that if there was a resistance, the stone would have to be projected faster in order to still hit the ground at 10 meters per second. Yeah. So just in case you ever find this question again, because it's not the first time they ask this, and it's not the first time that everyone makes the same mistake. This is what is happening. You are trying to think what happens with this velocity without changing other things like the velocity with it hits the ground. Yeah, so that's all with this question.